welcome to my YouTube channel. Today we are solving the third problem, that is if u is equal to log into tan x plus tan y plus tan z, then show that sin 2x into dou u by dou x plus sin 2y into dou u by dou y plus sin 2z into dou u by dou z is equal to 2. Here we need to prove that this LHS we should solve and we should get this RHS, that is we should get the value as 2. Let's write the given equation, that is given u is equal to log into tan x plus tan y plus tan z. Let's give as equation number 1. Here they have given sin 2x, sin 2y, sin 2z. No need to bother about this. We need to first differentiate this dou u by dou x, dou u by dou y, dou u by dou z. First, we'll differentiate dou u by dou x, u with respect to x, by keeping y and z as constant. We know that differentiation of log x is 1 by x. Let us consider this whole term as x. This whole term as x. Now, log x, what is the differentiation? 1 by x. That is 1 by, in place of x, what we have? Tan x plus tan y plus tan z. This is 1 by x, log x. We have differentiated only this log x, but internal differentiation we have not done. Now we should do that. Into, we have to differentiate only with respect to x. Y and z are constant, means this tend to 0. No need to bother about this too. What is the differentiation of tan x? Tan x differentiation is secant square x. Then this becomes secant square x plus 0 plus 0. I will rewrite this. Secant square x divided by tan x plus tan y plus tan z. Let's give as equation number 2. This is dou u by dou x. Now, same, this u should be differentiated with respect to y, that is dou u by dou y. Differentiating u with respect to y by keeping x and z as constant. Dou u by dou y, which is equal to, again same, log x means 1 by x, means 1 by tan x plus tan y plus tan z into internal differentiation. Tan x, that is constant because we are differentiating with respect to y. Then tan x is 0 plus tan y means tan y, that is secant square y, plus tan z means 0. Now secant square y divided by tan x plus tan y plus tan z into, that's it. This you consider as equation number 3. Now again differentiate u with respect to z by keeping x and y as constant. Here dou u by dou z is equal to, same, log x means 1 by x, that is tan x plus tan y plus tan z into internal differentiation. Tan x is 0 because we are differentiating with respect to z, and y also 0. Then z becomes, tan z becomes secant square z. This This becomes secant square z divided by tan x plus tan y plus tan z. Let us consider as the equation number 4. This is dou u by dou z. Now what we will do is, we'll substitute this equation number 2, 3 and 4 in the given equation, that is sin 2x into dou u by dou x plus sin 2y into dou u by dou y plus sin 2z into dou u by dou z. After this, substituting this 2, 3, 4 in this equation, we should get 2. Now put, let us consider this as equation number star. Now put equation number 2, 3 and 4 in equation number, that is star. I will do this in the next page. That is, the given equation is sin 2x dou u by dou x plus sin 2y dou u by dou y plus sin 2z dou u by dou z, which is equal to, let us keep sin 2x as it is. Dou u by dou x, we have already differentiate that secant square x divided by tan x plus tan y plus tan z plus sin 2y into secant square y divided by tan x plus tan y plus tan z plus sin 2z into secant square z divided by tan x plus tan y plus tan z. Now here in the denominator, see the denominator, here also tan x plus tan y plus tan z is common. In this also tan x plus tan y tan z, and here also tan x plus tan y plus tan z is common. Let us bring outside this whole term, that is 1 by, because why I am taking 1 by means it is in the denominator. So tan x plus tan y plus tan z, you take it outside, then the remaining term inside is sin 2x into secant square x plus sin 2y into secant square y plus sin 2z into secant square z. This whole term is in the numerator. Don't be confused, because it is in the denominator, this is in the numerator. Now what you do, you keep this equation as it is, only take this term or take this whole equation and solve it in the solve it aside, because after this, solving this, afterwards you put in this equation. Now sin 2x, we know that sin 2 theta is equal to 2 into sin theta into cos theta. This is the formula of sin 2 theta. In place of theta we have x here, so sin 2x becomes 2 sin x into cos x. This is about sin 2x. Now take this secant square. Secant square theta is equal to 1 by cos square theta. This is formula for secant square theta. In the same way, if we do sin secant square x is equal to 1 by cos square x. Now I'll substitute this term by this and this term by this. That is 1 by tan x plus tan y plus tan z into sin 2x becomes 2 into sin x into cos x into we have into secant square x. Secant square x means 1 by cos square x. In the same way, same formula, but we should change the variable. In place of x we should put here y. That is 2 sin y into cos y into 1 by cos square y plus again same, in place of y you put z, sin 2z into cos z into 1 by cos square z. Again, now here we have one cos square cos x, here we have cos square x, here 1x and here it becomes cancelled, and here also it will get cancelled, and here also one cos square cos y gets cancelled, one cos z gets cancelled, and here one cos z gets cancelled. Now we will rewrite the equation tan x plus tan y plus tan z. Here we have 2 sin x by cos x, because 1 we have cancelled, 1 is remaining, plus 2 into sin y by cos y plus 2 into sin z by cos z. Again 1 by tan x plus tan y plus tan z. Sin x by cos x, we have sin x by cos x. The formula for sin x by cos x is tan x. Then differentiation of tan x is sin x by cos x. We can also write this. In the place of sin x by cos x, I will replace it by tan x. That is tan x plus 2 into, we have sin y by cos y, then it becomes tan y. Here 2 into sin z by cos z becomes tan z. Here we have tan x, tan y, tan z, but we have 2 common here in these 3 terms. So I will remove outside. I'll write tan x plus tan y plus tan z as it is. If I remove or took common here 2, then the remaining terms will be tan x plus tan y plus tan z. Here we have here also tan x plus tan y plus tan z, and in the numerator also tan x plus tan y plus tan z. So this both terms becomes cancelled. The remaining will be 2. This is what we have to prove, that is RHS.